All right, these are the solutions to the particle motion quiz. At time of 0, a diver jumps from a platform, here's my diver, 32 feet above the water. The position of the diver is given by this quadratic, where S is measured in feet and T is measured in seconds. So when does the diver hit the water? We want when S is equal to 0. So 0 is equal to negative 16t squared plus 16t plus 32. To simplify my life, I'm going to divide everything through by a negative 16. So then I have t squared minus t minus 2. This is a factorable trinomial. Factors to t minus 2 and t plus 1. So we're setting these guys equal to 0. If I solve each of these factors, t is equal to 2 or negative 1. We're starting at a time of 0, so negative 1 doesn't work. Number 2, what is the diver's velocity at impact? Velocity is the first derivative of position, so s prime of t is equal to, well, if I just use my function here with the power rule, this will give you negative 32t plus 16. If I set this, and we want to find out at impact, well, that's at a time of 2 seconds, so s prime of 2 is negative 32 times 2 plus 16, negative 64 plus 16, and that's negative 48, and that's feet per second. Velocity is feet per second. All right, the next one. Says a particle moves along a line, so its position is given by this function. We have another quadratic. S is measured in meters, and t is measured in seconds. Find the displacement of the particle during the first 3 seconds. Okay, so we need to figure out where this particle was at a time of 0, and if I substitute in a 0 for my t's, that's just going to give me 1. And then also at 3 seconds, if I sub in a 3, that's going to give me 2 times 3 squared minus 5 times 3 plus 1. And so 18 minus 15 plus 1, so that's 3 plus 1, and that's 4. So displacement, if I start at 1 and I move to 4, that's 3 meters. All right, number 4, find the average velocity of the particle during the first 5 seconds. The average velocity is the slope of the secant line, and so during the first 5 seconds, let's figure out where is this particle at 5 seconds. So 2 times 5 squared minus 5 times 5 plus 1. 5 squared 25 times 2 is 50 minus 25 plus 1. So 25 plus 1 is, I believe that's 26. All right, so now we want to figure out s of 5 minus s of 0 and 5 minus 0. So s of 5 is 26. S of 0 is 1 over 5. And so 25 divided by 5, that is 5 meters per second. Number 5, find the instantaneous velocity when time is 6. So I need the derivative. And so s prime of t, I'll just go ahead and work it out first. So power rule for t minus 5, and then s prime at 6, 4 times 6 minus 5, 24 minus 5, and that gives me 19 meters per second. Number 6, find the acceleration. Okay, so acceleration is the derivative of velocity, or the second derivative of position. So let's see, s double prime of t would just be 4. And that is meters per second squared, sorry. At what value of t does a particle change directions? Well, the particle changes directions when the velocity changes from positive to negative or negative to positive. And so if I go back to my velocity, this guy right here, and set that equal to 0, my time is going to be 5/4. And just to check that, put it on a number line. If I plug in a value, whoops, don't know what that is. Plug in a test value to the left of 5/4. And let's see, that would give me a negative value. And if I plug in a number to the right of 5/4, that'll give me a positive. So I know I am changing direction at 5/4. Number 8, which of the following is the correct formula for finding average velocity? That would be this guy right here. Slope of the secant line. Okay, number 9. A particle speeds up when v of t and a of t are the same sign. It slows down when they are opposite signs. How do you know a particle changes directions? Well, velocity changes signs. When a particle speeds up, velocity is positive and increasing, so this would be D, or negative and decreasing, so this would be E. On the free response, at what time does the particle change directions? Well, that's when velocity changes from negative to positive. And so we need the derivative of position. Using the power rule, this would give you 6t squared minus 18t minus 24. We want this to set it equal to 0, and then we'll solve. And so just like I did before, I'm going to go ahead and divide everything to make my life easier by a 6. So if I divide both sides of the equation by 6, I have t squared minus 3t minus 4, and this factors nicely into t, let's see, minus 4t plus 1. And so setting each of these binomials equal to 0, I have a time of 4 or negative 1. So here's negative 1 and here's 4. Let's plug in some test values. So how about negative 2 and 0, and let's test 5. These are my test values. You plug these guys into your factors. So a negative 2 here would make this negative. A negative 2 here would make this also negative. The product of two negatives is negative. If I plug in 0, this will make this negative and this positive. So the product of a negative and a positive, whoa, positive, I meant to put a positive there, and a negative, sorry about that. And then let's test 5. 5 in this factor is positive, 5 in this factor is positive. There we go. So my answer to this one is that it changes directions at a time of, well, I guess we can't have negative time, so I don't even want to try that one. Sorry, I was just testing. I was just running with it. At a time of 4, the particle changes directions. Can't have a negative time, guys, because v of t changes from negative to positive. Where do we reach a minimum? Well, if you think about this, we have a negative slope and then we have a positive slope. So we're decreasing to the left of 4 and we're increasing to the right of 4. Oh, hold on though. It's asking for velocity. So velocity will reach a minimum when the second derivative changes signs. So let's go ahead and find that second derivative of position. I am counting this one as a bonus. So if you got it, then you got an extra point. And if you didn't, then no worries. Okay, so the second derivative position would have been, what, 12t minus 18. And if we solve for this, t is equal to, add 18 divided by 12, so 3/2. Okay, and let's just test a value. If I test 0 in this interval, that will make this negative. And if I test like a 2 over here, that'll make this positive. So I'm going from negative to positive, and negative to positive, as I showed you up here, is where I have a minimum. So at a time of 3/2. All right, a few more. Velocity of a particle is given in the graph to the right. The particle is in motion on the interval from 0 to 10. On what interval is the acceleration 0? Acceleration 0 is going to happen right here between 4 and 6. We are neither accelerating or decelerating. We are 0. The slope is 0. So from 4 to 6. At what time does a particle reach a maximum position? All right, so this is my velocity. This is my first derivative. I reach a maximum when my velocity goes from positive to negative. So right here at a time of 8. And where's the particle speeding up? Speeding up is when your velocity is positive and increasing or negative and decreasing. So positive and increasing would be from 1 to 2, and negative and decreasing would be from 8 to 10. And that's because v of t is positive and increasing. and or negative and decreasing. And I probably should use this notation instead of positive and negative. V of t is greater than 0. V of t is less than 0. And when is the particle at rest? The particle is at rest when our velocity is 0. V of t is equal to 0, and this is at a time of 1 and time of 8. And that's it, folks.